problems like this, if you see this on the final exam or the test 4, what I want you to do, to get partial credit, well, you could plug into the formula, or you could write down what you put in the TVM solver. Okay, like that. Because just be careful about how you enter your answers and everything. Okay, right. So the idea with this one is I'm going to review again how you do this on the TVM solver. So this is an annuity. So what it says is you're trying to replace a piece of equipment. So you're trying to save up for $800,000. And you want to save up for 5 years. And you're going to make equal monthly payments at 6.6% compounded monthly. Now, what you're doing is you're finding the payments. So I'm going to review how you do the TVM solver. And this goes like this. So you've got apps, the apps button. You want to press that first. Just go along, do this with me so we kind of review and you're reminded of how to do this. So you go to apps, finance, then press enter. Okay, and that's where the TVM solver is, and then press enter again. And you got to know how to set everything up in the TVM solver. So basically in this problem, it said 5 years, and it also said compounded monthly. So what that means is you're going to make 60 payments. 5 years, monthly payments is 60 payments. You can put 60 in there, okay, is what that is. The interest was 6.6%. If you're using the TVM solver, do not move the decimal back 2, just put it in, okay? The present value, we're doing an annuity. An annuity, the present value starts at 0, then it grows. So that's going to stay the same. Payment, we don't know what that is, okay? That's what we're trying to find. Put a 0 there for now, or anything you want to. Future value is what we're saving up for, so that's $800,000, okay? So that's the amount that we have there. And then this part is you're making 12 payments per year, because it said compounded monthly, and then you're compounding 12 also. These last 2 numbers will always be the same, and then you want to make sure that payment's at end in order to do that correctly, okay? Does that make sense? Okay. Now, what you do is you go to payment, just get your cursor blinking on payment, and then there's this solve button, which is in green. So you go alpha solve, but you got to be blinking on the payment. So it goes like that, and then there's your payment. It'll come out as a negative number. Don't do that. Don't put it in, like if you're doing this on My Math Lab, don't put a negative number in because you're wrong. Okay, you're paying money into this. So the answer is this. Okay, $11,290.42. Okay, so that's how you do TVM. That problem right there, you can do totally on the calculator. And if you're doing that on your test, you just write down what you put in your calculator. I usually just have you, like on the final, just have you fill this in and then go to your calculator. Okay, all right, because I want you to be able to do these things with technology. Okay, now on the next page, what we say is this says how much interest was earned in the last year. Okay, so what we have to do on this is we have to kind of go through and do this. Now I'm going to write down this number. So the payment, I'm going to write that down here. The payment we got was $11,290.42. Okay. So this is kind of what you have to do on this problem. You have to do 2 things. You have to, and remember this was for 5 years. You're saving in an annuity for 5 years. So what you have to do is you got to get the total interest. And it's good to write this down in words. Total interest for 5 years, for all 5 years. Okay. Then we're going to subtract the total interest for the first 4 years. Okay, so we got to do 2 things. The grand total of all the interest minus the interest accumulated in 4 years. Both of these things we do on the TVM solver though. Okay, so we're going to look at payments when we do this then. Okay, so what we would do on this then is, first thing we want to do is just figure out all the interest. Okay. So the way that you do the total interest for 5 years is you do this, okay? What you want to do is you're doing 60 payments, like this, okay, for all 5 years, 60 payments, $11,290.42 like that. Okay, now that's going to end up giving you how much money that you put into the annuity, and then you have to subtract that from 800,000. I probably need to write this more like this. So if you're going to find the total interest, remember 800,000. You want to figure out your payments, and I think you then subtract 800,000 like this. So I had that right. You want to go 60 payments in 5 years like this, and then times $11,290.42, and then minus the 800,000 like that. Okay, so we're going to do that. All right, so let me just do this first thing, and I'm going to do this on a clear screen on the calculator. All right, so I go 60 payments. We know what the payments are. That's what we figured out. That is $11,290.42. So if I do that, that's how much money is going in there, okay? I think I did doing this backwards. It should be the other way around. So you're going to do 800,000 minus the payments that you did, $677,424.20, okay? So remember, you're saving on this, so that's how much money you put in the annuity. The rest of it's interest earned. So what we would do then is we would just take 800,000 minus the 677,425.20, okay, like that, and this would be the interest on the grand total of the loan like this. Okay, so this is how much interest you gained by putting into the annuity. Does that make sense to everybody? Okay, we found the payment with TVM, 60 payments. We put in 677,000, but we ended up saving for 800,000. Okay, the whole thing. Now we're going to find the interest for the last year. So what you have to do is you have to do the interest for 4 years, the first 4 years. So then what you do is to do this, you kind of do the same thing. Well, 12 times 4 years is 48. So you're going to look at your first 48 payments like this. Okay, so we're going to do 48 times $11,290.42. Okay, that would be the amount you put in the first 4 years. Okay, all right, and this kind of goes like this then. So if I do 48,000 or 48 times $11,290.42, that's how much money that you actually put in over the first 4 years. So in the first 4 years, you put in 541,940.16 like that. So this is kind of what happens. What we figured out on the problem so far is that's how much money you put in 5 years. That's how much money you put in 4 years like that. So what we got to do is we got to figure out the amount of what the future value was after 4 years. Okay, so I'm going to do this. Now I'm going to go back to my TVM solver, and let me kind of show you what I'm doing on this. Okay, so I'm going to go back to Apps, Finance. Okay, like that. Now what we're going to do is we're going to figure out, we know the payment, so we're going to figure out what happened after, how much money is in that annuity after 4 years. So I'm going to start like this. Well, that's going to be 48, okay, because 4 years, after 4 years, you made 48 payments. You've got that. You started the annuity at 0. The payment, just leave it the way it was from the last problem. And then the future value, just put like a number there, because that's what we're going to find is how much money is in the annuity after 4 years. Okay, so we got the payment. Now what I'm going to do now is get the cursor blinking on future value and then go alpha solve. So that's how much money was in the annuity then. Okay, so what we end up having then is we kind of have this. We have 800,000 after 5 years. Okay, and what we have is we have $618,276.91 after 4 years. Okay, so we got that. All right, now remember what we're doing is we're finding the interest in the last year only. Okay, so what you would want to do on this then is we've already got the interest for the total 5 years. So we've got after 5 years, the interest is $122,574.80. They like that. All right, now what we got to do is just figure out how much interest was accumulated after 4 years. Okay, well, the way you would do that is you would have to do this. So after 4 years, here's what happens. Okay, you're going to basically have, you've made 48 payments. Those payments are $11,290.42. So I'm going to do that on the calculator. I think we already did that, didn't we? So we had $541,940.60, but the present value was $618,276.91. So if you look at the difference between that, that would tell you how much interest happened after 4 years. Okay? So what I'm doing with this essentially is 5 years, would be the 60. The 60 times 11,000 that's how much money I put in 5 years. What's the 800,000? That's the amount after 5 years that's in the annuity. So the difference is this. Over here, 4 years, 48 payments gives you this 541,000. If I subtract that from the 618 that I got from the TVM, that would give you how much interest was earned after 4 years. Okay, so I just do this. I'm going to do this on a clear screen on the calculator, so I would just do this. I would do $618,000, 276.91, and then minus 541,940.16. Okay, and then that'll give us the other magic number that we were looking for. Okay, so on that interest, this what this represents is this is the interest after 4 years. Okay, so that is equal to $76,336.75. Now, we got one simple thing to do to finish this problem up. So here's what happens. This is the interest after 5 years. That's the interest after 4 years. So what are you going to do to find the interest on the last year? You subtract the two, right? Okay, so you do that. All right, so to finish this up, the answer to the problem, you would just do this. Okay, you would just do the 122,574.80 minus this, and then that would give you the amount of interest that's earned in the last year only. Okay, so that's what that's doing. All right, so I'll do that on the calculator, and then that'll finish that up. Okay, so just go 122. Okay, so that would be the final answer. The problem would be $46,238.05, and the interest will get bigger as time goes on. That'll accumulate and get bigger and bigger. All right, now if you're confused, let me just explain what I did. Okay, one more time. Okay, first of all, we got the payment by the TVM calculator. Okay, that's TVM solver. That's where that comes from. So essentially, I'm doing two things. I'm finding the interest after 5 years. I'm finding the interest after, after 4 years, and then subtracting the difference. Does that part right there make sense? Okay? To get this amount, what did we do? After 5 years, 60 payments, right? 5 times 12 is 60 payments. We did that, got that number subtracted from 800,000. That's the number in your annuity. So that's how much interest is earned in the whole thing. Okay? Then what I did here is I went to the TVM solver to figure out how much is in the annuity, the future value after 4 years. So I did that, and then I did 48 payments after 4 years, and then the difference gives you that 46,000 like that. Okay? So what we end up doing then is that's your interest. Those are the two things, subtract, and that gives you the final amount we have there. Does that make sense?
I'm still kind of confused on the part of using the PDM solver to get the future value for that 618.
Okay, because I need to know how much is in the annuity after 4 years. And what happens on this, remember you have put in 48 payments. So what I did on the calculator a few minutes ago on the TBM, let me just bring up what I did. 48, of course, is 4 years, same interest rate, same payment. We already found the payment. And the reason I needed to do that is, see, I need to figure out how much is in the annuity after 4 years minus the payments I put in. Right. Right, so I use my TBM to find this value right here. Okay, so you got to know 800,000 after 5, 618 after 4. You find the difference in the interest. So that's the idea. Okay, mostly there's the technology on that, just using the TBM solver. Okay, so let's do. We'll wrap this up with a couple of things on the TBM, and then the last section we learn how to do what's called the loan formula is what I usually call that. So let's put this together. We're going to do TBM on this. So this says a bond is approved for a building, and it says you're going to make regular payments every 3 months. A sinking fund is just an annuity starting at 0. The amount grows after time. You got an interest of 5.4 compounded quarterly, 10 years. And then the obligation will be retired at a cost of $5 million. So what we're going to do on this then is we want to find what the value of those payments are. Now there's 2 ways you can do this. You can do I'm going to first of all do the formula, and this is the formula for a sinking fund. Okay, a sinking fund is just an annuity where you're finding the payment. So we're going to take everything and plug into the formula first, then look at the TBM solver, okay? So first of all, in this problem, the future value, what is the future value? That's going to be the $5 million, okay? That's what you're going to do with your fund. You're going to end up with $5 million. Okay, let's see. The interest, now remember you have to do 2 things. You have to do the interest rate divided by the number of times that you do compounding. If we use the formula, you got to move the decimal back to the left too. So that's going to be 0.054. So I'm going to just put that in as 0.054. Compounded quarterly, what does that tell you? 4 times, right? Compounded quarterly is 4 times. So that's what I is. We'll put that in, in the formula here in a minute, okay? N is always equal to the amount of time times the number of times you compound. So this one says that you're going to 10 years and 4 payments per year. So that's 40. Okay, that N in this formula is the total number of payments. That's what you want to get clear on if you're going to use this formula. Okay, so I is the rate over the number of times you compound. N is the total payments. Does that make sense what I've done so far? Okay, you gotta know what everything means in the formula. So now we're going to put it in. So the future value is $5 million. Okay, and then times, and it's going to go like this. The interest is 0.054 over 4. The denominator goes like this. It's 1 plus the interest again, 0.054 over 4 to the n power. N is 40, and then minus 1. Okay, now we're going to do that on the calculator. And you can do this in multiple steps. What I generally find that students do best on is if you just work with this problem in 3 steps. Okay, but you don't have to, but it's just the way I'm going to show this. So I'm going to take the 5 million, and then I'm going to do a couple of things on this. And I'm going to write down every decimal that comes out. You don't want to be lazy about that. You want to clearly write down everything that you get on this then. So I'm going to go 0.054 divided by 4, and just record whatever comes out. Okay, so that is 0.0135 like that. Then I'm going to do the denominator in 1 step. So the denominator that I've got highlighted, you're going to go parentheses 1 plus 0.054 divided by 4, close parentheses, to the 40th power, and then minus 1 like that. Okay, just record whatever comes out on the calculator. Most of the time it'll just be however many decimals your calculator holds. But you want to do all your rounding at the end. Okay, so it's going to go like that. All right, so I got everything in the formula. Now I'm just going to do this all together. So I'm going to do this like this. I'll go 5 million times 0.0135, and then divide by that number in the bottom, 0.7098189306. Do all your rounding at the end. Don't be lazy about that. Okay, so what you get is your payment is $95,094.67, and that's important when you're working in my math lab too on these problems. Is do your rounding at the end. Okay, now if you do the TVM solver, just do whatever the TVM solver gives you, but it's going to carry things out to several decimals. Okay, all right, so that's how that works out. What we're doing is we're finding the payment on that. All right, so I'm going to go, let's go back now to the calculator. So do this with me on the calculator. Go to Apps, Finance, TVM solver, and what we're going to do is just repeat the problem, but now we're going to do everything on the TVM solver. Okay. So basically, what N is in this problem is how many payments you made. So it's 10 years, quarterly payments. So what do I put in for N? 40, okay? All right, what's the interest? The 5.4. Don't move the decimal when you do TVM, okay? Present value is 0. Why? Because it's something you're saving for, so you start at 0. Payment, that's what we're trying to find. Put any number in there you want to, or leave the number you already had. Okay, future value is the 5 million that you're trying to save for. Okay, and then what are the last two numbers since it's quarterly? 4 and 4. Okay, like that. So that's how everything's set up. And then you want to go to the payment. So you go to get the cursor blinking on payment. Then you go alpha solve, and then it gives the same answer. Now it gives a negative. That's just the way that the computer is programmed, but it'll give you exactly the same answer. Okay, so that's kind of the idea on that. So so that's what I end up getting is that checks the answer on that problem then. Okay, all right, does that make sense? It's mainly just being familiar with the formula and what all the little numbers in the formula mean. If you do it by hand with the formula, that's the way I'd recommend you do it. And then TVM solver is easy to check with. Okay? All right, any questions? Okay, is everybody getting the TVM thing down? Okay, it'll be your friend. Okay, it solves everything for you. You just got to know how to set it up. Okay? All right, so let's do one on this one then. And this one I'm just kind of giving you what everything is. So I want to set up the formula. So I would start on this problem by, we're going to write down the formula. We're going to do this one on the TVM solver. So, but the formula is payment is equal to future value times I over 1 plus I to the n minus 1. So we're just going to plug everything in. I want to make sure you know how to do that, but then we'll do it on the TVM solver. Okay, so the payment is $200. So we'll just start off by plugging in the 200. The future value is 4,000. That's given. Okay, and then we have the interest. Now the interest I gave you. Okay, I didn't tell you the compounding, so you just plug it in. Okay, the difference in this problem is I'm not saying like 2% compounded monthly. It's already figured out for you. Then the denominator, you would have 1 plus 0.02 to the n power, and then minus 1. So that's the setup right there. I'm not going to solve this by hand. You would have to use logarithms. I've given you enough information to teach you how to do that, but we're just going to go straight to the TVM and do this way then in just a minute here then. Okay, so what you would want to go ahead and do here, let's see, this one didn't say anything about compounding. And we need to do this by hand. I wasn't thinking about that, but we need to do it by hand. All right, so what we're going to do is ultimately, now we'll go to the calculator ultimately, but we're going to do like, we have to use logarithms like we were doing the last class. We got to get that thing by itself. So the first thing you want to do is you want to divide both sides by 4,000. Okay, you want to get this isolated. Okay, and you can do whatever you can on your calculator. So I'm going to go ahead right now and just take this. We'll go 200 divided by 4,000. And that's going to be 0.05. So I got 0.05 is equal to, and now what I'm left with is 0.02 over 1 plus 0.02, and you can put that together if you want to, just write it like this. That's just 1.02 to the n power minus 1. Okay, so I'm going to do this by hand using logarithms. Okay, what we're going to do next is a good way to do this is just cross multiply. So I'm going to go like this. I'll go this direction. I'll get 0.05 times the whole thing, 1.02 to the n minus 1. And then this way I've got 0.02 like that. Okay, that's a proportion. So you can cross multiply that when you do that then. Okay. All right, you with me so far? Okay, now I want to do this. I want to get rid of the 0.05. So I want to go ahead and do that. So that would leave me with 1.02 to the n minus 1. Then I'll take my calculator and I'll do this. 0.02 divide by 0.05, and that gives 0.4. Okay, so I got that, and just a few more steps to finish this up. So what I want to do now is I want to add 1 to both sides, okay, because you're ultimately trying to get the 1.02 to the n by itself. 0.4 plus 1 is 1.4. All the work I did right there, seriously, was doing this. It was ultimately trying to get this by itself. So what I did is I had to get rid of the 4,000. I cross multiplied. Then I had to get the 1.02 to the n by itself. That's what all that is. Yes, you got something?
Why did you cross multiply?
Why did I cross multiply? Because it's a proportion. So what you have is a fraction equals a fraction. And you can always do that. So the idea would be like if you had something like x over 2 equals 3 over 4, you have one fraction equals one fraction, you go 4x equals 6, and then you solve it. Okay. The other way you could do this is you could just multiply by that denominator to get rid of the fraction, and you would get the same thing. Okay, so it works out either way. Cross multiplying is kind of a shortcut you can do. All right, now what we do is we do the natural log of both sides. Okay, one of the reasons why we learned about the log is so you can do this. Okay, and what are you allowed to do at the end? Bring it in front. We talked about that, so that would be 4 times ln 1.02, and then this is equal to ln of 1.4, like that. Okay, and let's see, we've got, why did I put a 4 there? That's an n. Okay, so I have an n there. Okay, then the last step is I divide by the logarithm 1.02. Okay, like that. Then I go to my calculator. Okay, so ultimately what I got to do on this problem is I got to do the calculator. So I go ln, natural logarithm 1.4, close parentheses, then divide by natural logarithm 1.02. And that'll give the answer is about, we'll just round that up to 17. Okay, so that's the amount of time that you do on this. A lot of these things I want to show you kind of by hand. You won't see anything like this on your final or on your test. This mainly what you're going to do is the TVM, the little bit more straightforward things, instead of these type of things. So I'm going to do one more like that. I want to just give you one more example, then we'll move on and do the next section where we learn one more formula. All right. So this one if you're a little shaky on what I did there, I'm going to do the same thing on this. And it's algebra is what I'm doing. So start by writing down the formula. For a sinking fund, it's payment equals FV times I over 1 plus I to the n minus 1. Okay, and we're going to just plug everything in. We're finding n, but this is the most difficult kind of problem because n is an exponent, so you have to involve logarithms. Okay, plug everything in. So the payment is 500. Future value is 8,000. And then the interest is 0.04. And then you would have 1 plus 0.04 to the n power minus 1 like that. Okay, so that's the setup of the problem. Now, what I would probably go ahead and do is, and I could have done this in my head, is you can just do 1 plus 0.04. So this part right here is 1.04. So what I'd end up getting is 0.04 over 1.04 to the n power minus 1. All right, so I'm going to pause there for a second. All I've done is plug stuff in. Is that good? Plugging numbers into the formula. Now, what our goal is we got to get this thing by itself and then do a logarithm. Okay? All right, what do you think the next step is? Divide by 8,000. Good choice. There's more than one way to do this. I'm just going to kind of take it this way. All right, want to get that, get rid of the 8,000. Take your calculator. And you can go 500 divided by 8,000. And that will end up giving you 0.0625 is equal to 0.04 times 1.04 to the n minus 1. Okay, like that. All right. What do you think's next? Huh? Cross multiply. That's a good way. Okay. Or if you want to, you can do this. Okay. You haven't seen me cross multiply very much this semester, maybe. So, I mean, you're just trying to get rid of a fraction. Okay. You're just trying to make that go away. So you got to multiply that to both sides. So you can do it this way if you want to. It's the same thing as cross multiplication. Okay. So it goes like that. All right. So what I've got left then, I'm going to write this as 0.0625 times 1.04 to the n minus 1 equals 0.04. Okay, like that. All right, so that's what I've done so far. A couple of algebraic steps gets me there. Again, your goal is to get this thing that I'm highlighting by itself. Okay, what would be the next best thing to do? Divide by that decimal that's in front. Exactly, divide by that. Okay, so we're going to do that. We're going to do this. Okay. Use a calculator, we'll end up having 1.04 to the n minus 1. You don't really need parentheses around that anymore. And then we just go to the calculator. Okay, so I'd end up having this. 0.04 divided by 0.0625. Write all the decimals down, so that is 0.64. Okay, all right, what's next? Add 1. Okay, add 1. Okay, you want to get the 1.04 by itself. So you want to do this. Okay, that's going to give 1.04 to the n equals 1.64. Okay, see, all that work was getting you to that point. Now what? Now we're ready for the logarithms, right? So we do natural logarithm of both sides. That allows you to bring the n down. That's a property we learned about logarithms. So it's n times ln 1.04 equals ln 1.64 like that. Okay, and then you're pretty well done. So now you get n by itself, you divide by the logarithm, and then go to your calculator. Okay, then you got it. There's a little bit of work involved in the algebra solving that equation. So we just do ln 1.64, close parentheses, divide by ln 1.04, and then that gives you the answer on that. So we end up getting n is about 12.6. I like that. That's a good exercise for students for solving equations. Okay, because you got logarithms in it. Again, that's one of the reasons why we learn logs. Okay, a lot of work in that. Okay, do you guys follow what I'm doing or not? Okay, most of that's just kind of standard doing things to both sides of the equation, and then you get that logarithm at the end. Okay, let's go ahead and take a break till 5 till, and then we'll finish up that last section.